Hi, my name is Bhumanand Barik and welcome to my YouTube channel. Today we will be understanding about a statistical concept that is known as confusion matrix. We have already seen logistic regression. Before proceeding for any other algorithm, we will be understanding this concept. Confusion matrix is a statistical term and it's a mechanism which is used in machine learning just to validate a model, how properly a model is estimating when implemented on a test data. So here we will be seeing some of the terms like accuracy, precision, recall, F beta score. All these things terms we will be understanding over here. So let's proceed. For binary classifications and multi-class classification, we have seen how logistic regression works. Apart from logistic regression, for classification kind of problem, we can use varieties of algorithms like k-nearest neighbors, k-means clustering, or random forest classifier. So there are various algorithms available in machine learning and data science which we can use for classification kind of problem. But the question is here, how do we know which algorithm is working best for our data set? So for understanding that, we need to check the accuracy or the percentage of accuracy, or there are certain parameters as per statistics which we need to check in each and every algorithm so that we can understand this algorithm fits well, or this algorithm fits well, or this algorithm fits well. So there is a concept called here confusion matrix. So we will see here how confusion matrix can give us clear understanding about our model. Let's see. So this confusion matrix is basically used after testing the model. As we know, we are training our data. After training, we are testing our data. So the model is trained first, then it is tested. So after testing the model, we want to check how the model is working, how proper is the model, and for that we are here using confusion matrix. So let's draw here confusion matrix. In confusion matrix, for binary classification, means here there are two options, yes or no. For yes we are taking 1, for no we are taking 0. So we will be creating a matrix in which there will be 2 rows and 2 columns. Like this, there are 2 columns and 2 rows. This upper side, column side, is predicted column, and this row side is actual column. So in this matrix, we can clearly understand the column represents the values of prediction and the rows represent the values of actually how many values or how much values are present. Actual values are present in row, column is having predicted values. First column is having 1 or yes, second column is 0. Like that, first row is 1 and second row is 0. So here, if we are predicting as yes and actually it is yes, or we are predicting as 1 and actually it is 1, it means the value is positive value and it is true. It means it will be considered as true positive. Now if we are predicting 0, means negative, and the value is 1, means it is false. First we are predicting negative, and the actual result is 1, it means it is false. So it is called as false negative. When we are considering prediction as 1, we are predicting positive, and that also false, it means it is false positive. Like that, when the value is considered as no or negative and actually it is true because we are considering negative and actually it is 0 negative, so it means it is true. So there are 4 options we have received here. One is true positive, true negative, false positive and false negative. So these are the 2 things which are correctly classified. If it is coming under true positive, then also it's okay. If it is coming under true negative, then also it's okay, diagonal. But these 2 things are quite dangerous. How and why those are dangerous, that I'll explain. We can clearly understand this confusion matrix with an example. Let's take an example of a medical where we have to diagnose a diabetes patient. So if the patient is having diabetes, then it will be considered as 1. If the patient is not having diabetes, it will be considered as 0. So here we can say, if our prediction is the person is having diabetes and actually the person is having diabetes, then it is true positive. If the person is not having diabetes but we are classifying as diabetes, then it is false negative. If the person is classified as diabetes but actually he doesn't have diabetes, it is false positive. When the person is not having diabetes and we are predicting that he doesn't have diabetes, this is true negative. So in this way, confusion matrix helps us understanding how clearly the data is classified. So now we can see here, if out of some amount of, suppose this is 20 plus 100, 120, this 130 plus 135. Suppose there are 135 records are present. Out of 135, 20 became true positive, 100 became true negative, 10 became false negative and 5 became false positive. So we need to check how many are correctly classified. This 20 plus 100, 120 are the records which are correctly classified, and these are the records which are incorrectly classified. Either it is predicted something else and actually something else, and either it is predicted like positive and actually it is negative, like this. These 2 like records, false positive and false negative, are the ones which are not correctly classified. So we need to understand in a data set what exactly do we need. Actually most of the people need this one, how many records are correctly classified, how many true positive are present, also how many true negative are present, that people normally see. So here a concept calls accuracy, and we need to understand what is accuracy. Accuracy is the number of records correctly classified divided by total number of records. So let's check. So here the formula of accuracy is true positive plus true negative, this diagonal, by the total true positive, true negative, false positive, false negative. So here the accuracy can be calculated as 120 divided by 135. So whatever the value comes, that will be our accuracy. But in this scenario, are we having the understanding of actually how many true positive records are present, or are we having understanding of actually how many true negative records are present? So for that, there is a different concept comes, precision and recall. So we will be understanding here what is precision and recall. As we can see on the screen, the formula for precision is true positive divided by true positive plus false positive. It means this is true positive divided by true positive plus false positive. So the precision is here the percentage of exact positive out of total predicted positive. So how many exact positive is here? true positive is the exact positive out of total predicted positive. So how much value is our total predicted positive? This is 20 is our true positive and this is false positive. So total predicted positive is 25, and how much is exact positive? That is our true positive. So 20 by 25 will be our precision value. So we can write here 20 by 25. So that will be our precision value. Now let's understand what is recall. So before that, let me note down the formula. Let me note down the definition of precision here. Here the formula is precision equal to percentage of exact positive out of total predicted positive. We can say here the total positive is true positive divided by true positive plus false positive. Here true positive is 20, false positive is 5. In predicted column you can say. Now let's understand what is recall. So what is recall? Recall is, here in place of predicted we need to understand total positive. This remove this predicted. Now the formula turns into recall. So here once we can write it here, recall percentage of exact positive out of total positive. Out of total positive means, what is our total positive? Total positive is actual positive. Here actual positive is this row. This 20 is actually positive, and this 10 value which are actually positive but it is not predicted positive and it becomes false negative, but these 10 values are actually positive. So this 30 out of 30, when we are considering this 20, this will be our recall value. So here in place of false positive, if we write false negative 20 by 30, it turns into recall. So recall formula is percentage of exact positive out of total positive, and this value is for positive result. This both precision and recall is for positive result, but recall can be also known as TPR. It means true positive rate. So if someone is telling true positive rate, it means he is talking about recall. Okay, so if like that we find out about true negative or precision of like negative value, we can consider here in place of suppose we are considering about precision of negative value. It means true negative out of total predicted negative. Total predicted negative means true negative plus false negative, because these are negative values and these are predicted negative values. So out of this total predicted negative values, how many true negative? That is for negative value. If we are considering about recall of negative, so in place of false negative, we can write it here false positive, because this is negative value 0 and this false positive is wrongly classified and this is correctly classified. So 105, 5 plus 100, these are total negative values. So here from the actual negative values, we are finding how many values are actually classified negative. So Tn by Tn plus Fp equal to recall of negative. It means it will be true negative rate. The way we considered recall of positive as true positive rate, in that way we considered recall of negative as true negative rate. So here true negative rate will be considered as 100 by 100 plus 5. 100 by 100 plus 105. So in that way we can find out precision and recall. So here precision and recall came because using accuracy we just found how many correctly classified data is present, but we did not have idea about how many actually positive rates are present, how many actually negative rates are present. No such kind of idea we had. That's why we used precision and recall. Suppose in a medical medical agency or in a medical, we have found false negative is higher. False negative is, we are predicting that the person is not a diabetes. We are again taking the example of diabetes. We are predicting that the person is not diabetes, but actually the person is having diabetes. So what can it cause actually when a person is diagnosed and found that he is not having cancer or diabetes? When we found the person is not having cancer or diabetes, that time the situation will be different. Actually the person is having cancer. We are predicting they are not having cancer, but actually the person is having cancer or having diabetes. So it can take the life of that patient. In that situation, what our goal is just to minimize this false negative. Even if a person is considered as diabetes and actually it is not diabetes or cancer, in that scenario what will happen, max to max the person will be diagnosed again and again, or he will be given medicine. But this kind of classification do not take the life of that patient, so it is less dangerous than false negative. So here our main duty will be to minimize the false negative. Just to minimize this false negative, we need to create our model. But in some scenarios we do not care about a false negative. If you do not consider this healthcare domain, if you consider some business domain, something like a retail domain, suppose there are some shoes or some clothes, some branded clothes are there, and suppose Peter England clothes are there. Peter England clothes are there. So apart from Peter England clothes, there are some other clothes which looks like Peter England. So in that scenario, we need to classify in such a way so that we have to understand how many actually Peter England clothes are there and how many clothes are not Peter England. So this is 1, this is 0. In that scenario, we have to understand. Suppose we are predicting the dresses are Peter England, but actually it is not. Then also it doesn't cause any life. We simply guess the idea. We are simply getting the idea how many wrongly classified results are appearing. So in that scenario, our true positive does matter to us. If it is increasing, true positive or true negative, it is increasing, then it's fine. We do not care about this false negative or false positive. So in that scenario, what exactly has to be done, that also we have to check. So in this scenario, what we can say, the domain expert will ask, I just want my model to focus on true positive. So give me the result so that the true positive must be higher. I am not concerned about this false negative or false positive. Or if the domain expert is asking, I am quite concerned about false negative. I do not want this false negative to be present. So your goal just to decrease this false negative as much as possible. So in that scenario also, there is a concept comes here like F beta score. we can write it here, F beta score. So what F beta score means? By changing the beta value, we can give certain kind of weightage so that we can get our data accordingly. Accordingly means, I'll tell you, suppose there are two models. In one model we get the precision of 60% and recall of 40%. In another model we got the precision of, suppose it is 50%. We are putting it at 50%. In another model we found precision of 80% and recall of 30%. So this is model 1, this is model 2. So here the question is, shall we go ahead with model 1 or shall we go ahead with model 2? But because the model 1 precision is 60% and recall is 50%, here model 2 precision is 80% and recall is 30% with respect to a positive result. So here the question is, we need to implement one more concept, that is F beta score. If F beta score is applied, then the formula will be F beta score formula will be 1 plus beta square into precision into recall divided by beta square into precision plus recall. This is what the formula of F beta score. Here if we are giving beta value equal to 1, so it will be simply 2 into precision into recall divided by precision plus recall. So this will be the formula. If this formula is implemented, simply whatever the value comes, suppose the value come like some 70% or 0.7. So this 0.7 value is the value which we are getting for F beta score, and for one model the value is 0.7, for another model the value is 0.6. So we should go ahead with this 0.7 value, because the more F beta value is inclined towards 1, the value like changes from 0 to 1. So the more the value is inclined towards 1, the better the value is, the better the model is. For us here actually, if the F beta value is increasing and inclined towards 1, it means we are giving more weightage to precision. For precision, we are giving more like weightage. We do not have that much focus on recall. If we are having precision and recall have same weight, similar weight, so we can give beta as 0.5. So in that scenario, if you put 0.5 at beta and rest of these things are quite same, whatever the value come, if the value is a value is 0.6 for one model, for M1 we get 0.6, and for M2 we get 0.5. So 0.6 is greater than 0.5 here. So 0.6 value we have to consider and we have to proceed with M1, because here as we have seen M1 model is having 60% precision and 50% recall. So as we are giving like equal weightage to both like precision and recall, that's why we should proceed with M1 model. If you see M2 model, the precision is 80% and recall is some like 30%. Here the weightage is not distributed properly. That's why we can consider this M1 model, as we are giving equal weightage to both precision and recall. Similarly, if we are giving more weightage of recall, suppose recall weightage is more, we can give here like 2, beta equal to 2. So if we are putting beta equal to 2 and we found like where the recall is higher, that model can be selected. And if, as I have told, if beta value is 1, so the formula says, suppose one model give 0.6 and another model give 0.8. So M2 is here having 0.8 value and M1 is here 0.6 value. As M2 is containing 80% precision and we are giving more weightage to precision, that's why M2 model will be selected. So in this way F beta score works, and when beta value equal to 1, that time F, we say the formula as F1 score. So we have understood in this video what is confusion matrix, how the confusion matrix works, what is true positive, what is true positive rate, what is true negative, what is true negative rate, false positive, false negative, we understood. Also we have understood here what is precision, what is recall, and what is F beta score and F1 score. In next video we can proceed with a different algorithm, and we can proceed with a different concept like ROC and AUC curve, which is quite required for binary classification. So hope you have understood the video. Please like the video and share and subscribe it. Thank you so much.